Hi, so today we are going to discuss a very interesting exercise which is from Leetcode. This is classified as medium. This is about finding the longest substring without repeating characters. So what does that mean? That means that if you have this input, you want to find the longest substring that does not repeat stuff, so you would have ABC because that doesn't repeat any letter, and the output is the length of ABC, which is 3. So how do we do it? Let's take this one. So I'm going to show first a more naive approach, and then I'm going to show an optimized approach, and we will discuss on both. So let's see how to do it with the more naive approach. We would have this input, for example. Let's say we store the current string starts with a P, and then you want to find like the longest substring in this one. So then you're gonna look in the next letter. Okay, does the next letter exist already in the current string? No? Great, we take it. Does the next letter exist already? Yeah, we reset. Does the next letter exist? No, it doesn't exist. We take it. Great. Does the next letter exist? No, it does not exist. We take it. Great. Does the next letter exist? Yeah, it exists. Then we reset it. In this iteration, we would find WKE, which is like exactly what they expect here. As long as next letter doesn't exist in current string, keep adding to current string. Otherwise, reset current string, right? So that's exactly what we will do. Let's store the result. Let's say var longest equals string dot empty. Then we need to iterate s, the input, var I equals 0, I less than s the length I plus plus current equals s of I dot to string var j equals I because we want to start with the next sequence, so to speak, every time. As long as the next letter doesn't exist in the current string, while current string dot index of j plus 1, then just keep adding to current string, current plus equals s of j plus 1, and then keep going, meaning iterate j. Okay, and then we do like a check, like if we have the current string dot length which is greater than the longest dot length, meaning if we find something that's longer than what we already have, assign it. Longest equals current. Okay, and then we essentially return what this exercise wants, which is an integer, which is the return longest dot length. Let's see how this works. We have an index out of bounds because at some point we are going to go out of bounds here. So we need to add a check. J less than s dot length minus 1. Let's redo this. All right, so this passes the acceptance criteria as case 1 with ABC, case 2 with a BB, and case 3 with a WK. It's not the most efficient code. Why exactly? Let's understand. So we have time complexity and space complexity. Complexity, maybe we can spell. So time complexity here would be O of n squared. No, n squared. The reason why this is because the inner loop has to iterate again for each letter, which is pretty inefficient. Let's reset this. The way to optimize this would be to use what's called a sliding window. Fixed size subsequence, which is part of a bigger sequence, can be moved along the larger sequence. Okay, so what does that look like? So let's start with by storing the result. Longest equals 0. What we're going to do here is we're going to use a very specific data structure, which is called a Hashset, to store what we found so far. Window is new hash of characters initialized by input.length. Again, we have two iterators. we're going to iterate the entire input s again, while I less than s of length window that contains s of I, while s of j does not equal s of I, so that remove j plus plus. And then, so this is the removal. Now we're going to add to the window. And we're going to say window that add s of I. And then we're going to do the same check that we did in the previous solution. We're going to say we found something in the window that's longer than our current longest, then we assign it. So if window that length, no, hashset has count is greater than longest equals window that count. Okay, and then we're going to return longest. Okay, so again, it works. What is the computational complexity? So we have time complexity and we have space complexity. Time complexity here will be O of n, because O of n, where n is the length of s, of input s. And the space complexity will be also O of n. And the reason is that we use a hash set to store the values that we found so far. What have we learned from this second example? Okay, why don't we use a list here? And the reason is that the reason why this will not work is because the list does not store unique values. So we specifically need hash set. Like if you use a list here, you're going to add duplicates because you're going to keep adding s of I. Okay. If you leave list and then you say, okay, let's run it, this will fail because it's going to add some duplicates. But if you leave hash set, you're going to eliminate the duplicates, because even if you say here window that add s of I, it's going to only add uniques. Okay. This is very good for, it's really optimized for insertion of unique values. It's really quick. So it's a much better choice for this particular exercise where you are specifically asked to find, without without repetition. So the hash set is perfect for this scenario. Okay, good. Yeah, I'll see you in the next one. Ciao.